A very good morning to all. I welcome you all to the day 4 of the 1-week online faculty development program on blockchain technology and its applications. In this day, the first session will be about the deployment strategies for blockchain projects. It will be discussed by Mr. Tejaswi Khanna. Mr. Tejaswi Khanna received his BTech in Computer Science and Engineering from Kurukshetra University in 2011, then MTech Computer Science Engineering from JC Bose University, YMCA, Faridabad in 2013, and currently pursuing PhD from Sharda University. He is currently working as an assistant professor at the Department of Computer Science Engineering, School of Engineering and Technology, Sharda University. His research areas include blockchain, mixed reality, social network analysis, and computer networks. He has been granted a patent in blockchain technology. More than 5 papers in international journals and in conferences were published by the speaker. I am very happy to have Mr. Tejaswi Khanna here. Tejaswi Khanna ji.
Good morning everyone. Good morning, sir. Thank you so much for the introduction.
Please carry. Thank you.
Thank you so much for this introduction. And I welcome you all for this day 4, session 1 regarding blockchain technology and its application. And the area that I'm going to be discuss is related to those faculties and the students. Essentially, it's my personal experience also, because from the past 2 years, I have been, guiding certain blockchain projects in my university. So the problems that I have faced as a guide, as a whole all-round manager of the project. So certain problems, certain challenges that I have faced. So I have come up with certain solutions. Essentially, these are deployment decisions that need to be taken before we actually start working and coding the blockchain. And I believe you must have worked yesterday on Ethereum. So let me just share my screen, just a second. Is this visible? Can anybody give me feedback? Is this visible?
Yes, it is visible.
Yes.
Great. So deployment strategies for blockchain projects. Just a little revision, or we must say little backup about what a blockchain is. So essentially, blockchain is nothing but a decentralized or a distributed ledger technology, which provides immutable, record-keeping mechanism of transactions or anything that happens on the blockchain network. The blockchain network essentially is a distributed peer-to-peer network, which is managed by not one single centralized entity. So all of the actions or transactions or anything that is happening over the network, blockchain network, happens and gets shared with each other in a real-time basis. So there are many different frameworks. Everybody has been aware of Ethereum, yes? Can you give me a yes in the chat box? If you are aware of Ethereum or Hyperledger Fabric or Corda?
Yes.
Great. So I wanted to be interactive. Thank you so much for this responses. So blockchain network is very important for certain specific kind of applications. So the first question which we need to ask before we start even talking about a project to be implemented, that somebody has come to you and shares an idea, sir, I have this kind of an idea, and can we apply blockchain on that? So this is a framework, not a framework, like a flow of idea about do we actually need a blockchain for that kind of a process or mechanism or system which the student has come up with, student or any idea that you have come up with. So this is not a framework which I have designed. This is a This is from a 2017 paper by somebody in Germany. So he published a very good paper, and he also then went on to publish an amazing thesis also on Bitcoin security analysis and something like that. So he has talked about a basic flow of how to identify whether you need a blockchain for your project or not. So as we know, first of all, we need to know that whether do we need to store a state. So state here essentially means the global state or the local state. So if you're just looking to store data for for a longer time, like in a database or something, so maybe maybe that might not be the answer here. So do we need to store states? Whether state means in databases there is a transaction, and transactions have different states, but either it is active, it is committed, or it is failed or rollback or whatever. So those kind of states can also be considered here. Okay, so if that is the case, then we go on to the second question: are there multiple writers? Writers here means very similar to the miners that we have in our blockchain network. So those people who are writing the transaction, making the transactions happen, and validating and verifying those transactions. So are there multiple participants in a single transaction? For example, insurance. For example, your degree verification system, or your vaccine distribution system. Quite very, you can say, multi-party competition is required in these kind of applications. Then you might go on to getting into a blockchain. If you're not looking, if the transaction is only managed by two parties, that's it, A and B, and that's it, then may or may not you require a blockchain. Second, can you use an always online TTP? TTP here stands for trusted third party. So can anybody share with me, what do you understand by the term trusted third party? In cryptography also we must have studied. So anybody, trusted third party? Anyways, so if there are some certain transactions which are happening between two participants, A and B, so we need a third party or some middleman kind of an entity which is trusted by both of the participants, A and B. So if that is the case, if we always need to use a trusted third party for any validation of a transaction or anything like that, then we don't require a blockchain, because blockchain, the whole philosophy behind blockchain, in fact the Bitcoin paper, was to provide digital transactions and verify those digital transactions without the use of a trusted third party. So if you feel that your system always requires some kind of a trusted third party to verify, validate any data entry that is happening or any transaction that is happening between the two parties, then you don't require a blockchain. Then are all the writers known? If yes, now see, first three questions are essentially for just looking at whether you need a blockchain or not. So now if you are moving further, then it means you require a blockchain network, or you require at least some aspect of blockchains to be applied to your solution. So are all writers known for the transaction? If yes, then two more points have to be checked out. If you don't require any a security mechanism, or no, not security, a verification process for onboarding the writers, the miners, or the nodes or participants of your blockchain network, then it is a permissionless blockchain, public permissionless blockchain that can happen. So Bitcoin is an example of a permissionless blockchain. You only need to download a software. Although right now, in the current circumstances, it's very hard to even mine one point to the sixth decimal of a Bitcoin in the normal laptops that we use. So prior to 3 years back, GPUs were used, but 3 years, 4 years before, now they have started using ASICs for mining the transactions. So in that aspect, you can, I mean, on paper, you can definitely get into the Bitcoin network since it's permissionless, but it's not viable for you to mine the Bitcoins. Next is if all the writers are already known, but are they actually trusted? Do the participants trust each other? The writers trust each other, the transactioner. So in that aspect, if they already trust each other, then though you anyways don't need a blockchain, because you can create a basic internal network system, basic chat messenger kind of system. Even Google Drive we should do, for all these things. But you require public verifiability also attached with those trusted authors. For example, in any licensing mechanism or accreditation mechanism, or like for an example, FSSAI is a food licensing authority which certifies the fast food or any ready-to-eat food product before it comes to the market. So it provides certain specific license to to the brand so that they can market the product out in the market. So that requires public verifiability, or in other terms, audit. So if there is a public audit required, then you need to have public permission blockchain. Else, you need to have a private permission blockchain. I hope till now it is quite clear. So before we head on to asking a question, sir, should we apply this blockchain into our platform or solution? Go through these steps. This is the, you can say, kind of the first step before you even start making a project. So this is a very basic or typical blockchain application design. It's actually from a paper that I published in 2020. It's about a traceability system in supply chain management. So we are looking at creating this kind of a private permissioned blockchain, keeping certain data public, but idea was to have a private permission blockchain. So what are we doing is to visualize the whole application, you visualize a blockchain network as specified in this circle, and then you need to have a web or app UI. Okay, so the web or app UI will be functioning as an interface between the blockchain network and the and the participants of the supply chain, Now, this blockchain network can be managed by the same manufacturer, wholesale, or it can be like a consortium blockchain in which the manufacturer has his or her own node here, for example, this one, or maybe wholesaler has their own 2-3 nodes in the network. So the wholesaler, manufacturer, retailer together can form the blockchain network as a consortium network also, or it can be deployed as a on-premises deployment, like in the cloud, at the manufacturer end, or maybe just at the end of the whole brand. For example, we've got Ranbaxy as a pharmaceutical company. So the Ranbaxy as a marketer or as a brand might have many vendors which are manufacturing their specific medicines and putting them out in the batches. So here the onus may lie with the Ranbaxy as a company as a whole, but not with the manufacturer, to maintain and manage and first of all set up the enterprise blockchain network. So the enterprise blockchain network essentially has different kind of functions. So we'll just talk about it in the next one. So what are the different challenges? What are the different challenges of creating a blockchain project? So first is design, then is development, and then is deployment. Although, as per my conversation in the past 2-3 months with many of the students and certain people who friends who are working in industry, and some friends are also working in the blockchain space. I have figured out one thing, that people are still stuck onto the design phase a lot. Deployment is still quite far-fetched, but design and development is still there, which is not totally clear in the minds of the blockchain developer as a team. So whenever we are looking to design, the first thing that is required for us to understand is the data schema. Data schema. So can anybody share with me the definition of data schema coming from database? Anybody? What is a data schema? So data schema, we might have studied something like, student, and then we put up certain attributes for the student. It might be his name or her roll number, and we put up some, name can be character or integer, and so on and so forth, right? Is everybody on same page? Yes, can you write it in the same? Yeah, thank you so much. So you specify the data schema, which means that you specify certain characteristics or properties which are there to identify your object. In blockchain terminology, we call this object as an asset. We call this object as an asset. So the whole idea of blockchain is to keep a track of this asset, or whatever transactions this asset is involved in, and what happened to the overall transactional result. So whenever we talk about that a block has been committed or a transaction has been committed, it means that the assets who are involved in the transaction, they have completed their transaction, and that is then recorded. So what are the different transactional data? Maybe we have changed some marks of the student. Maybe we have changed some grades of the student. So we have changed the certain attributes of this asset. In our example, it is the student asset. And who is doing that? Which means the faculty is making the changes, or maybe the exam cell is making the changes, or it's actually the student coordinator or the HOD or whoever is making the changes. Do they have those access to that data which is connected to this asset? So this kind of data schema needs to be very well thought of before we even start creating our blockchain code and start making transactions. So attributes can be their ID. ID means name, roll number, other aspects, color. And there are many things which are associated with identifying an item. One thing which is very important for blockchain networks, which I have studied and understood, is that every asset needs to be, you can say, mapped with some other actor asset. Actor means somebody who's making the transaction. So who is performing the transaction on some asset that needs to have, either you can call it owner ID, or you can call it transfer ID, anything which specify mapping between the item and the participant of that network. Okay, here participant does not mean the actual node who is validating the transaction. Participant can just mean even the user can also work as a participant. We'll talk about that in the next slide. Next is very, very important, is this actor asset. So actor asset, as an asset, it also requires attributes, that what's the location, what is the name, what is the designation, which company is it, what is the address, and all these things. But the most important is the role and responsibility of this actor asset, which actually means what are the transactions which are allowed for this actor asset to perform on certain item. So for example, I'm taking the same student example because that's very relatable for each one of us. And I don't want to take the banking example because it's very cliche. Okay, I hope that's okay with you. So student has got some, some data from the past 2 years, but maybe in some, because of some issue, the student got, we call it back or supplementary in one of the subject. Okay. Now the supplementary, the whole process of the supplementary is that the student will take repeat the course and do get the marks. So now it's not necessary that the same faculty who taught the student in the regular term will also take the subject in the supplementary term. So there would be a different faculty who would be given the responsibility to make the change or to upload the marks in simple terms. So to upload the marks, we need to give that transaction or the rights to that faculty. It's very similar to what we call as the ERP rights, which you must have seen. But yeah, that is the similar concept here also as when we talk about the actor asset or roles and responsibility. Clear? I hope this is clear to everyone. So we'll just move on to our next slide. Yeah. So now that you've understood what is the data, what are the transactions, and what are the different data that you require from your user or from different participants, we will look into some pre-deployment states, decisions. So as we discussed, we need to first of all know what is the asset and how the assets are connected with each other, how they are identified and certain other aspects. Then comes your stakeholders, their attributes and their functions. As I talked about the actor assets, these people are the stakeholders. Okay, so stakeholders are also the participants of the blockchain network, and they can or cannot have a node working on behalf of them. Okay, so okay, and then if you must have seen in the conventional softwares which we get people to work on, we talk about the flow chart, the data flow diagram or the flow chart, which beautifully explains how the whole system will function from top to end, top to bottom. But in blockchain, it's easier. It's easier and recommended from many of the researchers also that we should have a transactional flow diagram also. Transactional flow diagram will require this to be identified as the relationship between the assets, who owns what at what time, and who transfers the ownership from one stakeholder to another stakeholder, and what are the functions which are responsible for this transfer. All these things should be identified and visualized beforehand. Fourth is data storage. So in a proper setup, we don't want the data to be stored on the blockchain itself. Now that's very counterintuitive, right? Because we are talking about keeping records immutably and all these things in a blockchain because it's transparent, secure, everything is there. But keeping the data actually in the blockchain will make it quite heavy, because how the blockchain networks function, either it is permissionless or it is permissioned. The idea is to keep the copy of the ledger, at least the whole copy of the ledger, with all of the participants of the network, or at least the important participants of the network, nodes of the network. So you must have heard of the term called as blockchain database, or we also use databases to store the actual data. However, the transactional data or transactional hash gets stored in the blockchain. So this is one decision that you have to take. What level of data are we storing in the database, and what level of data or transactional hash or other aspects are being stored or shared in the ledger, blockchain ledger, essentially. So blockchain, now for example, you have a car, you have a home, you have so many of your assets at your home. But whenever you are making the record of the assets, you are using a basic Excel sheet, yes? So just now analyze or connect these two things, that all of the assets are not in the Excel. There is only a representation of that asset in your Excel sheet. Similarly, the transactional data is not stored. Transactional data means there are documents stored, there are PDF, there are so many important things if you look at not only financial transaction, but different use cases like insurance, healthcare, governance, and all these things. One transaction requires multiple of documents to be verified, and all those documents are called as the data for that transaction. So that data should not be stored in the blockchain, or should it be stored in the blockchain, or what level of data should be stored in the blockchain, what level of data should be stored in the database, and what view should the user and the administrator have while performing the queries. So next is query processing. So query processing is very similar to obviously the DBMS, because we are storing the data in the DBMS. So what kind of query can be processed over the blockchain? So that is these 5 points are the pre-deployment decisions. I hope everybody is on the same page. Please share with me if I'm going very fast or slow, or if anybody have any questions, we can take 2 minutes to answer some questions. Yes? Because now we'll go on to discussing certain deployment decisions. Let me just go to the chat box if there are any. Yeah, thank you. Yeah, anybody has something to say? No, thank you so much. So now, deployment decisions, which means that you want to deploy a blockchain for your solution. So what are the decisions that you need to take care of while deciding which blockchain to choose, who is going to host the blockchain nodes, what consensus algorithm are we going to use, what are the different onboarding, what can be the different onboarding process on all these things. So these are the points that we'll be discussing, and we'll at the end of it, we'll have a little case study. So blockchain type. So essentially, there are 4 major types of blockchain technology, which we need to take a look at and keep in mind while we are deploying the blockchain for our solutions or for any kind of a project. So first point is definitely, do we need a blockchain? Now, if we need a blockchain, then what type of blockchain do we require? Either it is public permissionless, or it is private permissioned, or it is hybrid, or it is consortium. So here is a very amazing, a summarized way to share the difference between all these 4. So I'll just not look at this slide and just share my experience of understanding which one to choose. So public or permissionless blockchain is the one which is totally transparent. It is actually following the decentralization aspect to the core. Okay. So which one for what purpose can we choose public permissionless is the one. For example, if you require to audit data from the public's eye, for example, there is a government body called as CAG, which is there to audit the different PSUs, government bodies, and other governing bodies which are there to provide certain services. So CAG requires to share the data into the public. Okay. Now, if CAG can create their own blockchain platform in which that data which they have created and compiled as the result of their auditing process, that data can be made public to the normal public. So that can be made accessible. So in that aspect, you can also have one of the public representative as part of the blockchain network. So that's a very that's one of the example. Performance issues are always there because public blockchains, since they are not governed by anything, they are totally open. So you can have issues or disparity of performance of systems which are part of the network. Scalability, definitely. Bitcoin's transactional capabilities, maximum 7 transactions per second, which is not as scalable. Security is definitely there. The issue of security is there. However, in the use case thing, cryptocurrencies definitely is one of those good application which has been utilizing this public blockchain. For example, this Ethereum and Bitcoin and similar variants of Ethereum and Bitcoin. Certain applications require, as I told you, CAG, document verification, validation. So if you are looking, if there is a company which is looking to accredit some different bodies, or they are the certifying authorities, then they can go in for a public permissionless blockchain. Private permissioned blockchain. This is where the enterprise blockchains are looking forward to. So enterprise blockchains don't prefer public blockchains. They are looking always as a private instances of the blockchain. So because we can have a control of access on the data and the participants of the network. Disadvantage is that you need to trust the participant before you add into the network. Auditability, since obviously it is not a fully decentralized mechanism or network, so auditability is definitely a point of issue. It can raise concerns whether you are being transparent in terms of your auditability or not. Use cases are essentially for supply chain and for different types of value chain. Supply chain has a huge market for such level of this thing. And in fact, my PhD thesis is also in supply chain. And then where you have an ownership of an asset. So you should have a private permission blockchain. Hybrid means certain data needs to be public and some data needs to be private. But both of the data are being maintained by the blockchain nodes only. So the access control, the performance and the scalability is always a better bet, because if you look at this thing, that there is a blockchain called as Ripple. So Ripple boasts of about I think 1800 to 2200 transactions per second, which is still not as comparable to Visa or MasterCard, but it still boasts of this. That is because that it's a hybrid or consortium kind of a blockchain. So when we talk about hybrid or consortium, they are functioning similar in a similar pattern, wherein hybrid also requires you to have multiple participants managing the blockchain. But in private, you can have a single entity managing the blockchain network. It definitely defeats the purpose of 100% decentralization. But blockchain is not there to solve the philosophies. It is there to solve the problem of the industry. So the problem of the industry can also be solved with hybrid and consortium. So for medical records, where certain data needs to be kept public, certain data and majority of the data needs to be kept private with the different stakeholders of the network, then you require hybrid or consortium. Okay. Yeah. So next is hosting of nodes.
Excuse me, sir.
Yes, yes.
May I know the difference in between consortium and hybrid?
So essentially, hybrid can have, so when we talk about consortium means all of the participants who are managing the blockchain network are part of the same industry. So you will have a consortium of medical, practitioners only. Or if you're making a consortium of banking participants, then it will be only banking banks or people who are involved in banking. They will be participants of the blockchain network and managing the transactions. However, that condition is not purposely with the hybrid blockchain. So hybrid blockchain can have, suppose we have insurance mechanism. So car insurance, I need to have the car vendor, I need to have the insurance party. I also need to have a mechanic or some person who can verify the state of the car. So 2-3 different industries need to be part of that network. Okay, so in that aspect, we need to we need to have hybrid. There is a very thin line of difference between hybrid and consortium in that aspect. Also, second difference can be, but it's not necessary that it will be purposely, followed by both of the blockchain, is that hybrid can have some data which is public and some data which is private, but consortium essentially talks about private data only. They are talking of internal network. For example, we have something called as a Rosetta network of businesses, or if you want to look at a purely consortium blockchain is R3. So R3 is a consortium. Their blockchain is called as Corda, CORDA. You can Google that. That is a purposely for banking consortium. Cool? Is this
okay,
understood?
sir? One more thing.
Yeah.
I want to discuss a use case where electronic health record is being shared among multiple stakeholders of healthcare, but we want to make it patient centric, means patient
should be the
owner of the health record. So what type of the category it will fall?
So even if patient is the owner of the data, here in any of the case, patient can never be the owner of the blockchain. Patient can never be the one, or end customer can never be the entity which can manage or set up a blockchain. We still require some blockchain to be set up by the pharmaceutical industry or medical industry. So those can have a hybrid blockchain being set up by different hospitals, or you can have 5 hospitals together, 5 pharmacies together, and then you can have a medical record blockchain. So hybrid can be the best bet for that aspect.
Oh, okay, thank you, sir. Thank you.
Cool. So we'll move to the if anybody has any questions. Sorry. So we move to the next point which we'll need to look at is who will host the nodes. Now, nodes are what? Nodes are like miners. Nodes are there to produce and validate the blocks. So it is the responsibility of the nodes to add new blocks into the blockchain, and also obviously they create a block using transactions, right? So they are characterized by the production and dissemination of valid blocks. They are miners, but not wallets. So there is a very it's always a very difficult way to explain any blockchain application, because we are using multiple terms to explain one thing. Miner, I'll go to my sketchbook very quick. So we can have miners, we can have nodes, we can have participants, we can have users. So many words which are loosely used to explain the same term. So miners and nodes are the ones which are actually validating the blocks. Their main concern is to validate the blocks. The participants or the users. So user, we'll just talk like user is like the customer who is just buying something from the industry, or who actually invokes the transaction. This is the only purpose of the customer is to invoke a transaction on a very basic level. The participant is the one which is the actual participant of the network. So it is the participant of the network, which means all the rules, regulations, they can also be called as the stakeholders. Like you have, if you are going to a supply chain of fruits, then you would have a distributor, an aggregator, a retailer. All these retailer, aggregator, distributor, wholesaler, etc. These people are the participants or the stakeholders, and they are participants of the network, as I was just discussing. So these may or may not have nodes in the blockchain. It's not necessary, but the rules are governed by the voting mechanism of these stakeholders. If the 5 stakeholders of the network say that from now on, we will charge 5 paisa for every transaction, this is the rule. Now that rule will be coded into the smart contract, and then all the things will happen. Then that smart contract will be deployed on these nodes or the miners, and so on and so forth. So validation of the block is managed by the nodes or miners. That is not the responsibility of the stakeholder or participants. They are just there to be the face of the network. And the users are the one which invoke the transaction using something called as a wallet. You must have yesterday you must have done something with the wallet, definitely. So wallet is the one which is used to interact with the blockchain smart contract. But who is doing it? It is the user who is interacting. Now, it doesn't mean that the participant cannot interact on the blockchain using their wallet. They also utilize a wallet for this purpose. But for all the governance and the policies of the network, they are responsible for that aspect. Okay, we'll come back. So I've just written what is the whole process of validating a transaction. I'll just take a second to skim through it because it will take some time. So all the new transactions are broadcasted to all the nodes in a blockchain network. That's how it has happened. Each node collects new transactions into a block. Okay, so if they find a difficult proof of work for its block, so they find to validate that block, that I have found the transaction and it is valid. So for that purpose, they do some kind of computational, intensive work. So that can be proof of work, that can be proof of stake. We are in the consensus algorithm comes in place. We'll talk about that in the next slide. But when a node finds a proof of work, which means that now the node says that yes, my transaction, which I have recorded in my block, it is valid because I have a proof of work. Now, this transaction should be committed into the block. Now that information will be broadcasted to all the nodes. Now all the nodes will accept the block only if all the transactions are valid in the block. Okay, so they accept it and they do it. So this whole purpose, this whole process of getting the broadcast, sharing it on the broadcast, working for the proof of work or whatever consensus algorithm is applied, and then sharing it on the broadcast network again, and then accepting that okay, the block is there. This is a very computationally intensive process and not recommended to be done. Don't try this at home. So for this purpose, there are many blockchain node providers for actual, running blockchain applications. So there is something called as to resolve these technical issues. There is something called as blockchain as a service companies, which manage all these necessary tasks, activities to keep the blockchain infrastructure operational. So, there are, for any node to work on the network, there are many prerequisites. Okay, one is you need to have 99, at least 100% of uptime, network uptime. Your node cannot go down in the network. Secondly, it needs to have very higher storage space because it needs to store the ledger, copy of the ledger. It needs to have one thing which needs to be considered is that the node the blockchain transactional speed is purposely kept at higher speed as compared to the disk writing speed. This is what I have read in some papers also. That I'll repeat it again, that the speed with which the transactions are happening over the network, they are committing over the network, the writing speed on the disk is purposely kept a little lesser as compared to the transaction speed. So, I have still not been able to find out the answer. I'm still researching. But yeah, so the idea is to have a higher disk's writing speed in your system. So SSD is, solid state drive in place of HDD is recommended. So your system should have at least 512 or 1 TB, or maybe higher level of SSD, which are quite expensive to have at your home individually. The node provider deploys the core resources and uses the necessary technologies and infrastructure to set up and maintain the nodes connected to the blockchain. So now, can I ask a question from you right now? Anybody? If we are deploying the blockchain on a Ethereum platform, what are the different steps that we require? Just a basic, if you can just give me a very basic. What are the things that we require? Only the prerequisites for Ethereum. Have you heard of the term truffle, ganache? I'm sorry, I could not attend the session yesterday, but I'm sure you must have read about it. So for, okay. Okay, great.
Yes, Solidity and MetaMask only covered. Yes.
Solidity and MetaMask only. So Solidity, you must have coded it on either Remix.
Yeah.
Yeah. So Remix is like a, you can say, it's an emulation of a node, which compiles the code, which then runs the code, and it also provides you a simulation of different nodes in the blockchain, right? You have at least 10 nodes that they provide to you. Every node has 100.
Writing smart contracts especially.
Yes. It is specifically for compiling your smart contract. But then when you compile your smart contract, you also go to deploy your smart contract. So to deploy your smart contract, you select a node. If you remember, there are 10. You select one of the nodes on top of that. I'll just see if I could share it with you in some time. So that node requires a lot of things, which means it needs to have a connection with the blockchain, which means the starting block and the current block, or the connection via API or the URL. So if in the actual, you can say production level, you require to have a blockchain either simulated to us, or we use MetaMask to directly, deploy our contract onto the ETH network. Either it is test network or the mainnet. So similarly, if you want to utilize a truffle framework provides you three things. One is your blockchain simulation, which goes by the name of Ganache. And then there is truffle framework, which is used to migrate and compile your contract. And then there is something called as Drizzle, which is there to provide you front end for looking at the whole transactions and blocks that are happening. So these are the necessary technologies or infrastructure that they are talking about here. So if for Ethereum, if you're utilizing truffle framework, then this is the necessary technology. If you're utilizing Hyperledger Fabric, then you need to have a virtual machine, or not a virtual machine. In today's times, they use Dockers as a containers. So we require containers. We connect those containers with our blockchain framework. So very beautiful IDE, that is Microsoft Visual Studio Code. If you must have done Microsoft Visual Studio Code, they have provided an extension in that Visual Studio Code for Hyperledger Fabric, and that works very seamlessly. Although I have worked it in the older version 1.4, I have yet to work properly in the 2.0 version. Anyway, so just like cloud service providers, there are certain services which provide you blockchain as a service for the purpose of hosting your nodes. So you can get down to GetBlock 2019. This is one very unknown entity. Or you can have blockchain with AWS, IBM, and other big players of cloud have also jumped into this blockchain as a service providing. So if you're looking for a production level network, you should definitely go with some cloud provider for providing you node hosting. Okay. Next, and very, very, very important, is consensus algorithm. So if you are going on with this Bitcoin blockchain, or you're going to deploy something on the Ethereum blockchain, you don't have a choice to choose the consensus algorithm. But still, you need to know which application is better suited for my, which consensus algorithm is better suited for my problem statement. So why do we require consensus algorithm? It's like it's to reach a common agreement between the different nodes. We require a consensus algorithm. It's like the heart of the blockchain app. It is the one which defines who chooses what are the different different rules and things which are there to provide you. Just a second, guys. One second. Yeah. So to reach to the final truth of the ledger and all these things, you need to have a consensus algorithm. So there are different families. The first is proof of family. So I call it proof of family, but it is like proof of work, proof of stake, proof of elapsed time, proof of existence, and proof of burn, and many of them are there. Still, researchers are going, which one is better, which one is not. So accordingly, you can choose according to the scalability and transactional throughput. Two things. There are two things which you need to look at: is the transactional throughput and the scalability of that algorithm. So like as I told you, Bitcoin has a scalability of, or transaction throughput of 7 transactions per second. However, I believe Ethereum has a transactional speed of 12 to 15 transactions per second. But if you just go to Solana, if you just go right now, also if you would like, you can Google Solana. Solana is claiming to have about 10 to 15,000 transactions per second. And please check it out. So they are utilizing Ethereum's framework, but using a different consensus algorithm. So you can this is a very big advantage that you can use, not using Ethereum, but you can use Solana to deploy the same application, and then you can have a comparative analysis. So this can be utilized as a research aspect also. Next is a BFT family. So BFT is a Byzantine fault tolerance, which is there to handle malicious nodes. So this concept and also the next two, Raft and Kafka, these three of the algorithms purposely come from the distributed system era, and they talk about practical BFT, RBFT, which is redundant or recurrent BFT, DBFT. There is a family of BFT algorithms also. Now, BFT algorithms have a higher.
Are you talking about Apache Kafka?
Yes, yeah, Apache Kafka. So
event handling, event streaming tool. So how it can be useful in this scenario?
So Hyperledger Fabric is utilizing, sorry, not Hyperledger Fabric. Hyperledger as a whole utilizes a host of different tools along with Raft and Kafka. So if you go with Kafka, Kafka or Raft, these are the consensus algorithms which are utilized in Hyperledger products. Although I have not much studied on Kafka, Raft is being used in the Hyperledger Fabric essentially. I think the Sawtooth, the Hyperledger product called as Sawtooth, it utilizes Kafka. So there are different things. See, it's an event only. It's like an event only. Consensus algorithm, how it functions, if you break down the actual algorithm, any of the consensus algorithm, it's like
here we are talking about if we are saying events, it means transactions.
Actually sub-transactions. To validate a transaction, there again it requires a lot of process to validate one transaction, right?
To reach for common agreement, we have to do some sub-transactions.
Yes, I
We are
mean
talking,
we should not call
as
it sub-transaction. That's a wrong word. I am sorry for using that, but they are,
event.
yeah, they are events. They can be called as events, and also automated events. That is where smart contract comes into play. So yeah, for that purpose, we require an event-driven approach for the different communication between the entities while they are validating the transactions, right? It's because see, it's not a proof of work kind of a thing. It's not a proof of stake kind of a thing. Wherein, if I have found a proof of work, then I say that the transaction is complete. It is not like that. Kafka or Raft say that, okay, you have said that this transaction is completed. Okay, we'll ask 10 more people. If 10 more people say that, yeah, cool, then we move on to that. I hope that's clear now. Okay. Yes? Yeah. So which consensus algorithm gives us better scalability, better transaction, or do we actually require a higher transaction rate or not? Because see, for a degree verification system, we might not require a higher transaction rate. We might require a higher accuracy. So for that aspect, using BFT might be a better idea, or maybe Raft. So that depends. So Hyperledger, as a whole line of products, it provides you different choices which you can choose for your own purpose for your problem statement, whichever you're trying to solve. Okay, so yeah, cool. Next is your onboarding process. Now, this is specifically only for those blockchains which are permissioned blockchains or hybrid or consortium. So for a public blockchain, we don't need any onboarding process. You just download a software. If your system supports the application, if your system supports the network supports the application, then you're good to go. But if we are talking about permissioned blockchain, then we need to have a way to validate new members. It is very similar to a KYC process, know your customer, or in this case, know your company process. So we need to have whatever documentation we need to have, or whatever is the way to validate a new member. We need to always have a process for that thing even before we start the blockchain. We can definitely have our own dummy nodes to do these testing purposes, but once you go into the production level, you need to have a proper onboarding process. Reason being, I'll tell you the reason. Suppose you created, you got into a beautiful Ethereum blockchain, and you wanted to, no, I want to earn some money, I want to mine some Ether. Yes. So now you created a node. Although Ethereum is not, it is said to be highly unlikely that it might get hacked. But once you are on the node, your information goes to a potential hacker or malicious nodes. People who are trying to get into the network by exploiting some loophole. So you have created your system node, you have created your Ethereum node. But your system is not very secure. You have not created the proper security mechanism and all other aspects in your machine. So you can very well be a missing link or a weak link for the attacker to hack on your system. So in a public blockchain, if you are getting attacked, you will be removed in a very short period of time. But what if in a permissioned blockchain, there is one system which has got attacked by a hacker or something? Who is the one, and how? What are the different things that we need to keep in place for managing those problems? Onboarding process starts from that, because in the coming slides we'll see that. And then there are legal agreements. Now, legal agreements are definitely need to be in place, just like you provide smart contracts. So I'll share with you one diagram in some while, which is talking about managing the members using smart contract also. Next is governance and policies. So this is a very important aspect. As you can see in the diagram, I have purposely chosen this gears to represent a working complexity of any big system. If you have a huge system in which there are different participating entities for the purpose of verification, validation, computation, and other important operations, you need to have governance in place. Governance means not only just writing the rules and regulation, but also a way to enforce those rules. So herein, those rules are definitely, some of the rules are consensus algorithm. Certain aspects are handled by the, in fact, major aspects are handled by the smart contract that you write in your Solidity or JavaScript or Go language. So how do you enforce rules? How do you enforce rules? How do you enforce punishment if somebody deviates from those rules? What are the incentives? What are the penalties? And how do you handle malicious or compromised nodes? These are some of the points for governance specifically. Okay, so governance means that all the consortium members or the stakeholders of that network come together, sit together, they ideate and purposely write down all the rules which are required for the smooth functioning and desired functioning of their system before we start coding and deploying. Also, there needs to be policies for fault tolerance. Fault tolerance means that any system can go bad. Maybe there is some power issue, there is some system issue. A number of issues can cause a system to fail, right? So what are the policies during that time, or for that situation, or to handle that situation? Policies for onboarding, as we just discussed, and exit policies. If somebody wants to leave the network, then what to do? It's like a HR policy. It's like an HR policy, And then the last is data collection policies. Which entity can collect which data from, via what kind of device? So are you using IoT? So is that IoT secure enough, or what are the security parameters for that IoT device which your system has right now? And other aspects. So data collection, is this actually just collecting data via human input, or it is using automatic data collection, for example, via RFIDs or QR codes and things like that? So these are certain policies and governance issues which you need to take care while you are discussing this talk today is not for those people who are actually making the project. It is for those, in my head, it was for those people, those faculties, those people who are guiding the project, who are overall managing the project. So they have a team of at least 4, 5, 6 students or people or whatever. So for them, I have created this whole talk. Next is your level of decentralization. Yes.
Is there any regulatory authority in India to give some standardized framework and all for implementing the blockchain, if we are talking about private or hybrid?
Not as of now. And essentially, the question is a little incomplete. We can never have a regulatory authority to handle all of the blockchains. We can have regulatory authority in the industries. For example, financial industry have their own regulation for blockchain implemented in the financial sector. We can have a real estate regulatory body which can then provide regulations for implementing blockchain networks in the real estate sector, and similarly in education sector, healthcare sector, and so on and so forth.
So are they worldwide or country-wise?
See, that depends. That depends. That all depends. Since it's a consortium, you can have a world. You can have like SARC. So SARC is 8 countries. Similarly, we have G7, which are 7 to 8 countries. But they are all consortium working for different missions. So if your system requires you to have a collaboration with the entities which are beyond your borders, you can set up a regulation for these kind of things also, right? For example,
no such ISO, ITU type of standardized institution working for that.
yes, they would require to create. For example, a very basic example is there. Right now we have FSSAI for food licensing in India. But now if we want to create a blockchain application for the food sector, which is under the purview of FSSAI, then they need to provide us the guidelines. I mean, that's how it should happen, because a regulation can only happen from a government body, or at least a body in which there are more than one accountable entities, right? Or for example, in insurance we have not insurance, in stock exchanges we have SEBI. All these things are there to regulate. But right now, to regulate blockchain as a technology for all the different industries, I don't think that is the right way to look at it. It's rather individual industries can regulate their own.
Sir. Enough discussion. Thank you, sir.
So a level of decentralization. Next is whether we have, is there a need for central entity? Or if we require, more than one centralized entity, but with limited capability. Like in an educational institution, we have a higher authority, which is the VC office, and then we have the deans, and then the HODs, and then the faculties and students. So we have not given all the power to the faculties. We have given some power to the faculty. We have given some higher power to the HOD, but the HOD has lower power as compared to the dean. So this hierarchy needs to be visualized in terms of decentralization or a distributed network. So although this can happen while you're making the network, that's not a problem, because it's just a matter of changing a little code and changing a little request and rules and responsibilities for any entity. So this is not that as important. Next is use of network generated data. So we see that after every 10 minutes, the Bitcoin commits one block. There are a lot of transactions, a lot of data. Cool. Similarly, 4 to 5 minutes, it is the time for Ethereum. So every 4 to 5 minutes, there are some data which is generated. So that data, we need to be sure how we are using the network generated data. What are the different policies regarding use and ownership of that data? Who owns that data? So, almost half an hour back, ma'am was asking me that we want to create a blockchain of healthcare record, but we want to make it patient-centric. Yes. So I believe patient-centric means that the owner of that data should be the patient, which means if somebody wants to access that data, the request should first go to the owner, the patient, whether the patient wants to allow or disallow the access for that data. So these kind of use and these kind of policies need to be framed beforehand. If you are applying any AI/ML or big data analytics on the network, on that generated data, then that also needs to be figured out firsthand. Also, it can be a modular approach, but at least in terms of the ownership of that data, that's very important. And that's why I shared in the very initial slide, there is an ownership transfer model, which is talking about aspect of this thing. Okay. For example, one idea is only allow active members to access the data. And if a node leaves the network, it loses access. It's fairly very simple statement to say, but to actually code it and all these things, it takes up a very big understanding and how the access is revoked and all these things are there. This happens using smart contract only, not a problem. So yeah, now we'll go through a little bit of case study. So we have got still 22 minutes left, and I want to share with you, and I would want you to do some exercise also. So using what we have discussed today till now, I would like you to just visualize a supply chain of apples. Can you do that? Yes. Apples, oranges, anything, any fruit which is favorite of yours. Just imagine that there is a supply chain of that fruit. So, वैसे तो I like mangoes, but I create, I'm much more well versed with the supply chain of apples. So, apples start from some place, then they go to the wholesaler, the aggregator, distributor, and then to the retailer, and then finally to the consumer, which is me. Now, these are what are called as supply chain actors. Yes. So now, please, if you can just figure it, just go with me to find out what are the different, identifying points for the apple, which is the item asset here. Can you just give a little brief? Can anybody help me out with this? I mean, I have already done it. It is. I want you to do some exercise with me because I want it to be interactive so that it doesn't feel like just another lecture. So can you share with me something like if you have an app, if you are buying some fruit, what can be the identification mechanism of that fruit? So you have an apple. So apple will start from some manufacturer, right? So who is the grower of that? So we'll give some identification that who is the grower of that apple, okay, or any fruit that you're saying. Then what is the batch of that apple? So what is the quantity of that apple in kgs? 50 kgs, 100 kgs, etc. Okay. What is the you can say breed or species of the apple? Okay, so is it a Kashmiri apple? Is it Kinori apple? Is it what kind of apple? We need to know. For example, we have oranges, Nagpuri orange, and other oranges also. So like that, you can think about doing that. So this is how you define on a very basic level, on a very overview level. We are just defining the item asset here. Okay, and one last thing which I was talking about was the owner ID. Okay, so the same thing, the same principle can be implemented to any kind of use case. Even on the healthcare issue also, we can also have that. So if we are looking at healthcare issue, I'll just share that also. If we're looking at healthcare record, so suppose we are talking about HR HREC. Suppose we are just calling it HREC. So this is our item. This is our item asset, which is which should be owned by the patient. Okay. So first of all, what is the record? We will have a record ID, and then we need to have the name of the patient, the different diagnosis that the information related for the patient. So the patient must have gone through this thing. So information related to the diagnosis means all of the information. What was the disease? What was the treatment? What was the medication? Who was the doctor? All these things are stored in one object called as diagnosis. I have kept it like this. You can keep it however you like. So this is the item that you want. With this, you will map one thing called as the patient ID. Okay, got it? Patient ID. So this will be used to identify the owner of this information or this record. And that's what we are talking in terms of ownership of the data. Can you just give me 1 second? My laptop is getting low on battery. Just 1 second. Okay. So this is the first part that we can. Next is your. So what we have done is we have done the schema data schema we have figured out. That similarly, we'll figure out the asset, actor asset. So suppose in this supply chain, you have grower, distributor, retailer, etc. In the healthcare instance, we can have hospital. So you can have a hospital ID, you can have name, you can have the role. You can have, then you connect this hospital ID with the record ID. Okay, so this record is connected with this hospital, or you can connect that same record ID with the hospital ID. So this is all the same that what we do with databases, right? So it's not very different from databases, but just the idea has to be, approach is a little different. Okay, then we have different functions. So we can create the asset. So we create the both item asset as well as the actor asset. While we are creating the actor asset, we also provide something called as the functions. But in the in blockchain, these functions are nothing but transactions. So we create different transactions, and then we provide access to transactions and map them to the different stakeholders or the actors. Okay, so the stakeholders will be mapped with the different functions. So in the function, there is a little info that you give that who is the owner of that transaction at that time. If the owner of that transaction is not what we want, then that stakeholder cannot invoke that transaction, cannot call that function. In more programmatical terms, the object cannot call the other function. That's the basic thing. Okay. This framework is further divided into web or app interface. I will not go into web or app interface. You know how it can happen. But the certifying and auditing agencies and the supply chain actors, they will be required to collect data. So you can have different collection framework. Either you can have NFC or RFID or barcode or QR code. All these people will access the information on the product to verify whether the product is correct or not, whether the fruit is expired or not, whether the fruit is, if they are claiming that it is a Kashmiri fruit, Kashmiri apple, then whether, scanning the QR code, the information is clearly visible or not. All these things have to be managed by using these techniques. Okay. So this is a framework of understanding the data collection process and the blockchain, you can say data schema and the functions and assets in this framework. And it is specifically for a supply chain traceability. So this is a diagram being published from, this is a model called as fruit block layered model, which was published in 2021. We are short on time. Any questions till now? We still have 2 slides. Any questions till now? Anybody has any questions? Okay, great. Now,
I am having one query.
Yes, sir.
Actually, you have told at the beginning that we are having the 4 types of blockchain technology.
Yes.
Basically, where we find these easily adaptable type of technology in context with the hybrid and the consortium?
Are you talking about the use cases where hybrid and consortium blockchains are well suited for?
Yes, definitely.
Okay. Good. So, so the hybrid one, as I told you, if you are looking to have people from different industries, but they can't share every data for them. For example, if you look at this example, thank you so much for muting. Now look at this example. This is another model which have been published. So now this is utilizing a consortium blockchain. So consortium blockchain is always required when we cannot have a single entity managing the blockchain network. Okay, what do you mean by single entity managing the blockchain network? It means that single entity validating the transaction, essentially. So this example is of a blockchain-enabled vaccine delivery system. Can you please mute yourself? There is so much noise coming from somebody's end. Yeah, thank you so much. So the idea is the beneficiary who wants to get a vaccine done, they go to the vaccinating agency. The vaccinating agency can be a hospital, it can be somebody. So what do? They have to now ask at least 1, 2, 3, 4, 5 different types of information in order to verify whether this beneficiary is eligible to get the vaccine or not. Okay, so this can be considered as a multi-party authentication mechanism. Now, when the multi-party authentication requires you to have multiple participants from similar, backgrounds, like here we have blockchain-enabled vaccine supply chain, so it is healthcare. Electronic health records, so it is also healthcare. Healthcare facilities and frontline workers, this is also healthcare, but only the difference is the UIDI database. So we are looking at a consortium blockchain. So, and similarly, even if you have 1 or 2 entities which are not from healthcare, maybe if you are now incorporating one more point here, like health insurance. So suppose you want to incorporate health insurance with vaccine delivery, or maybe health insurance with health records, you want to incorporate that. So electronic health record, healthcare facilities are healthcare industries, but the industries which is insurance and banking, they are from totally different industry, but they have to come up together. So in that aspect, you will require a hybrid blockchain. Although, see, functioning of hybrid and consortium are very similar. There is no difference. It's just a word given to some blockchain which looks different. That's it. But whenever you are looking to have multiple participants to validate or verify one single transaction, any transaction, anything, then you require to have a blockchain which is of the nature of consortium. And
so can we call these all participants as stakeholder of the system?
Yes, these are the stakeholder of the systems.
So how can you differentiate vaccinating agency and the healthcare facilities as they are denoted by different shapes?
Yeah, so
do consensus algorithm work in this case also?
Yes, sir. Consensus algorithm is the soul of blockchain that will always be there. That is, even if you use any blockchain, you will have to require consensus algorithm. That will always be there. So we're coming to the first query, that how I differentiate vaccinating agency from these points. See, ma'am, vaccinating agency is only taking in the query. Vaccinating agency is not the verifying agency or the participant which is responsible for validation and verification of the blockchain. Here, vaccinating agency is not the participant of the consortium blockchain. Only, except vaccinating agency, all of these blockchain, supply chain, healthcare record facilities, and frontline workers and this thing, these are the participants and validating entries or stakeholders of this consortium blockchain. Vaccinating agency is only there to query from the blockchain to get to know whether this beneficiary is eligible to get this or not. I hope it is clear.
So, sir, in this case, if we want to connect all the scenario with APIs,
Yes,
so
yes.
Total 6 APIs will be there or 5?
Ma'am, see, here it will be only one API for vaccinating agency to do this. Since vaccine information and healthcare condition verification and other verifications are already done on the blockchain, the vaccinating agency only require their interface to connect with the blockchain. Okay, I have put these double-sided arrows to specify that these are part of the blockchain. Vaccinating agency is only taking in the query from the blockchain. So there will be only one API.
It is just like front end and back end case.
Yes. Yes, it's actually very easy only. It's just that people have created such a hype about blockchain applications that it feels very, huge. But it is like a front end, back end thing only. Just that the approach needs to be a little different.
It is just because of a good trainer like you.
No, I am not. Thank you so much, but I am
Thank
not.
you, sir.
Thank you. So yeah, so this is one another kind of a thing which is using in two places. It is using blockchain. One is here a consortium blockchain. It is also written blockchain enabled vaccine supply chain. So vaccine supply chain will provide information to this consortium blockchain. So it's a 2-3 layers of blockchain implementation. So the blockchain-enabled vaccine supply chain, that is not a consortium supply blockchain in its own sense. If you just zoom it and pick it up as a different kind of standalone product, then okay. So that is the difference. Now this is not my. This one was my diagram. This is not my diagram. This is how you can actually share with the students how to do what to do. Okay. So they need to understand the data. What to do with the data. Either you need to keep it off chain or on chain, as I talked to you where to store. Then the blockchain network. These 2-3 things are being managed by the DevOps operations. Okay, so this is just another term given to it. What you need to know is you need to understand how to deploy a blockchain network, whether on a private local host or on a mainnet or even on the cloud. So if it means on the cloud, you are utilizing the cloud service provider. That is the most better recommended way to do that. Then the transaction. So whether it is privacy, privacy has to be managed in the transaction, or if you have to put all the transaction first in the blockchain. So it is actually from an enterprise integration, it is events. Okay, so all the events are like this. So anything that happens, if a privacy is breached or a transaction has happened, that is considered as an event from the integration point of view of a developer. Although middleware is not our concern as a blockchain developer, you want to have a middleware, you want to have connectors for your UI, good enough. You want to show the blocks in a very good way and beautiful way, good enough. But for us, it is not as required. Similarly, the apps. This is the app which is there to just give you the view of the digital assets that you have. Digital assets are still on the blockchain, but to view them, you need to have the UI. For them, you need to have API gateways. So you can use, when I was doing 2 years back, I attended an FTP wherein we were taught to create a blockchain on our own using JavaScript. So we would run a get request, run it on the browser. But when we wanted to push some data onto the blockchain or to showcase onto the UI afterwards, we would use a post request. So we would use a Postman service. It's a tool. So for testing the transaction. So you can do that for just testing purposes. So, so that's how a full stack framework can function. So there's still 3 minutes left. Anybody has any questions, you can also connect with me over email or my phone number is there. My name is Tejaswi Khanna. I am very thankful for this opportunity. And actually, this is my first time ever I am giving any talk in an FTP. So thank you so much, Professor Raghu and his team of JP Institute of Information Technology for giving me this opportunity to talk about blockchain. Thank you so much. Is there any questions?
Thank you. This is
participants, if you have any doubt, please ask. Participants, if you have any doubt, please ask.
Okay, no questions, no problem.
Thank you, Mr. Tejaswi. Very nice talk on the deployment strategies of blockchain application.
Really, sir, Tejaswi sir, you put very well effort for making the tough topic as a simple way you explained. It's very nice, sir.
Thank you so much. Thank you so much. Thank you so much.
In general, actually, the one who is working in this area can well explain the things because since he is working in this area as a PhD thesis, so obviously he has to explore more things and also at the same time he has to justify his supervisor also, obviously. So he has to very well prepare, otherwise he cannot do that things. And at the same time, your knowledge also helpful to our participants also. And one more
And
thing I would like to share here is in middle, some of the participants asked that some ISO standards and all. And I would like to put my version of this here is that ISO, OSI, all these things, standards are fixed based upon the process that you follow. Okay, they won't give the standard to the product. They will give the standard to the process that you follow. Either it may be CMM level, capability maturity model in software engineering, or it may be any other thing. So it will be followed based upon the process that you follow. CMM level 0, initial, repetitive, like that. Some level 0, 1, 2, 3 will be there. So here whatever the guidelines for the design of the blockchain applications are there. So it is always better to follow the spiral model of software development. So first to start with the small prototype, then analyze that prototype, then go for the risk analysis, then add some more modules, again go for risk analysis. So that is what the advantage of the spiral model, where risk assessment can be done. And because of the agile technology, the people are now moving to the agile and developing this product. So in general, we all the people usually neglect the software engineering as analysis, design, coding, and testing, and then we feel that is nothing more than that. But so many
yes,
things are there where you can go for developing of, especially blockchain-based applications, where the security, risk, trust, privacy, these kind of things are involved. Obviously, you must be very careful because once you put the smart contract on the production, you cannot take it back. It is just like a hardware failure. Once hardware was designed and manufactured, if there is a failure, you cannot take it. Only thing is you need to recall all the car, like for example, in the case of car and all, you need to recall and you need to resubstitute with this thing. The same way, once it was kept in the production environment, it is very difficult for you to take it back. So that is the reason you need to run in the test environment for at least for some time. Then you should know the risks about that. Then you need to think of which is to be standardized, which module to be standardized. Then that module to be placed in the production environment. So in this
yes.
way, we need to go for the deployment of the blockchain applications. This is what I would like to put before, in addition to the what Mr. Tejaswi has told. So, and one more thing is, participants, if you have any doubt, please ask so that you can have a nice discussion with Mr. Tejaswi.
Thank you, Vice
Yeah, I think there is no doubt from participant side. Mr. Tejaswi, I am very thankful to you. You have nicely explained and put up the first. You started with the how to choose the blockchain project. Then what type of what are the different categories in the blockchain projects, and then you have gone for the design issues, then schema design, then moved on to the way of deployment, and finally you have told one use case related to that. Then now current ongoing that is vaccine system, that also you have explained very well. I think with this lecture, our participants have benefited by this.
Really, sir, he cleared the whole picture of the blockchain overall.
Thank, thank you, thank you, thank you. I'm really glad. I'm really glad. Thank you so much.
Okay, sir. So thank you, sir.
Okay, thank you. So I'll take leave. Thank you so much, everyone.
So our next participant will join. Next speaker will join. Okay. So let will take. Let will call the next speaker.